Today's lesson is going to be on 1B, graphing linear equations, and mine is going to start on page 3. If yours is on a different page number, then flip to the end of your first section and figure out what page number needs to go here. So you're going to notice that I have labeled my page as graphing linear equations. We're going to go over a few vocabulary words first. Remember that you can pause at any time to take down notes or rewind if you need to go back over something. So the first vocabulary word we're going to look at today is slope. The ratio of the vertical change, which is y, compared to the horizontal change, which is x. In any equation that we see in slope-intercept form, we're going to use m to represent slope in our equations. Our second vocabulary word is y-intercept. That is the location on the y-axis where the line crosses. We're going to label that as point 0b. B is going to be our y-intercept value. Now there are a couple of equations we need to remember. You're going to get this handout and you need to glue it into your notebook. So the first equation that we are going to take a look at is our slope-intercept form. That is equal, y equals mx plus b. M is the slope and b is the y-intercept. The second is point slope. We'll look at that a little bit, but not too much. The third one that we're going to take a look at is our standard form. Our standard form is y equals ax plus by equals c, where a is going to be a positive value. Now I could have a minus sign here, so just be careful. You can go ahead and cross off the fourth one. We don't need that. And we want to remember that all vertical lines have the form x equals a number, and all horizontal lines have the equation y equals a number. Now, I have starred the first one and I have starred the third one. Those are the two that we're going to take a look at today. The first example we're going to look at today is actually graphing a linear line that crosses through 2 points, and then we're going to find the slope from there. So our example that we're going to look at is 2, 6, and negative 4, 9. What we want to do is we want to plot each point on our graph. Now you're going to get a sheet of these, so cut them apart and glue one of them here for example 1. So the first point we want to plot is 2, 6. The x is 2, so we're going to go to the right 2. And the y value is 6, so we're going to go up 6, and we're going to put a point here. The next point is negative 4, 9. So we start at the origin, we go left 4, and the y value is 9, so we go up 9, and we plot our point. I'm going to connect my 2 points with a line. I'm going to use this paper to help me here. You can use a ruler if you need to. And now I have created a linear line that goes through those 2 points. So what I want to do now is I want to find the slope. Now remember from our definition up here that slope is the ratio or fraction of the vertical change compared to the horizontal change. So now I'm going to calculate how far down I'm going to travel to be in line with this point, which is 1, 2, 3. So I went down 3 points. So I'm going to write negative 3 over. And how far to the right I need to go to get to this point? 1, 2, 3, 4, 5, 6. So my slope is down 3 to the right 6. Well, if I look at this, it looks like it can be simplified because 3 goes into 6 twice, and 3 goes into itself once. So my slope is in fact negative 1/2. We're going to need to use this later on when we're graphing. So now we're going to take a look at the next example. The next example, or the next 2 examples, are how to graph a line using the slope-intercept method. So here we have y equals mx plus b again. Remember that slope is the m and the b is where the line crosses the y-axis. Now underneath slope it says that we want to write it as a fraction. That means if it's a whole number, we're going to place it over 1. Or if it's an integer value, we're going to place it over 1. In order to do this, we want to plot the point 0b, and then we want to use the slope to find more points. So this example shows that they plotted the point 0,1, and then they went up 3 and to the right 2. Or you can go right to up 3 to plot the next point, and then they connected their line. We are going to use the slope of m equals -1/2 and a b value of -1. But I want you to write the equation first and then graph it. So we have y equals, our m value is -1/2, and then we put our x, and then typically we would use a plus sign, but because we have a -1, we're going to write it as -1. So now what we're going to do is we're going to start at our b value. So our b is located at 0, -1. So 0, -1 is our first point, and my m is -1/2, which means I'm going to go down 1 and right 2. So I'm going to come down 1 and to the right 2. And I'm going to do another one just so that I have a longer line. From this point, I go down 1 and to the right 2. And then now I connect my 3 points, and I have the graph of the linear function y equals -1/2x minus 1. All right, let's try another example. Remember, you can pause at any time. We want to graph y equals 2x minus 3. Our m is in front of our x, so that's going to be 2. But remember, we need to turn it into a fraction, so we write it as 2/1. Our b value is a -3, so we're going to turn this into 0, -3. So I'm going to first plot 0, -3, and now I'm going to go up 2, right 1. So I'm going to go up 2 from here and to the right 1. From this point, I'm going to go up 2 and to the right 1. And now I have 3 points that are going to form my line, and I will connect them. Again, you can use a ruler or a piece of paper. And now we have graphed 2x minus 3. Now you'll notice that this example is increasing and this example is decreasing. Well, this had a negative slope and this has a positive slope. So all of our positive slopes rise from left to right, and all of our negative slopes fall from left to right. We have 2 more examples we're going to take a look at, both of them kind of doing the same thing. This time around, we're going to start with a standard form and turn it into slope-intercept form. Now remember that slope-intercept form is in the form of y equals mx plus b. So I want to bring everything away from the y value over to the other side. We're going to start by subtracting 3x from both sides. Now be careful, because the 3x doesn't come away from the 6. It's its own piece because they're not like terms. So we now have -2y equals -3x plus 6. I like to write my variable first so it looks like my slope-intercept form. We have one more thing to get rid of, but we're going to divide everything by that -2 so that the y is alone. Negative divided by negative is positive, so we have a positive 3/2 x, and then 6 divided by -2 actually turns into a -3. And so now, just like before, our m is 3/2, and our b is -3, which we are going to write down as 0, -3 as our point. So we start at 0, -3. We go up 1, 2, 3 to the right 2. From here, we go up 1, 2, 3 to the right 1, 2. And we now have our line for our equation. Our last example is 4y plus 3x equals 16. The only difference between these two is that the x came first in this example, and now the x is second in this example. So we are going to subtract 3x from both sides. 4y is equal to negative 3x plus 16. Divide everything by 4. Notice I do it separately. Y is equal to negative 3/4 x plus 4. Our slope is negative 3/4. Our y-intercept is positive 4. So our point 0b is 0, 4. So this time we're going to graph 0, 4. And now we're going to come down 3 and to the right 1, 2, 3, 4. Come down 1, 2, 3 to the right 1, 2, 3, 4. And we have our line. And we will do some more practice in class.